Hello, today we'll be looking at some IB-style problems and how they relate to inverses and other polynomials, things that we've been looking at or exploring and reviewing over the last few weeks. So this is to demonstrate, by the way, that it's important to know the basics when it comes to mathematics, like what are the basics of logarithms and how do you evaluate logarithms. But to truly understand, you have to know a little bit more, you have to be able to dig a little deeper. And so the way IB styles their questions, it's not enough just to know how to evaluate a logarithm, you have to know what it is and what it relates to. So that's what these questions are about. So I'll get to it. The first thing we're asked to do is to sketch the graph of the inverse, y equals the inverse of f of x, when this is the graph of f of x. So what I do is I start with the asymptotes. This asymptote right here, to be inverted, this asymptote is x equals 1. The inverse is going to be y equals 1, because the domain and range are going to switch places. This is 4, 0. If I invert that, I'm going to have 0, 4. So that gives me a point to graph. I also identified a point that's approximately 2, negative 1. So when I go to negative 1, 2, approximately, I have a place to start drawing my graph. And I also found the intersection with my asymptote, which is over here when I invert it, and that gives me a graph that looks like this. Now I label a key point for the reader, and I also label the asymptote just to identify that it is an equation of a line, and that is the lower limit of this particular function. I label f inverse of x, and then I state its range. Now here all I did is, and it said state the range, so in IB land that's worth 1 mark, and when I make the statement I'm done, I get everything. But before you start taking an IB exam, I need you to sort of spend some time reflecting on your solution and sort of communicate as quickly as you can how you came across this. And so I just leave a note that the domain of f of x is any number from 1 to infinity. That is, here's the original function. It did not have any values left of 1. All this function is defined for is values of x that are greater than 1 up to infinity. So since the domain of the given function is 1 to infinity, the range of the inverse function is 1 to infinity by definition of inverse. Finally, the last part, which is if you look at the mark scheme, there's 2, 1, and then 4 marks. So clearly the meat of the problem, the one that's going to involve the most depth of reasoning, is part C. So you look at the mark scheme, you can get a sense of how much work and effort you're going to put into this. So what I have to do is glean from clues that are given to me on the graph values of A and B. Now you can do this using intuition, but sometimes it's better to be analytical, plus it really helps to communicate when you use a more analytical approach. Given the fact that I have the point 4, 0, that means I know the y value is 0 when x is 4, in spite of my knowledge of A and B. When I substitute that into this equation and exponentiate to get rid of the natural log, I end up with the truism, since e to the 0 equals 1, that 4a plus 1b is going to give us 1. There's no other points that I'm absolutely certain of. I could make some inferences, but it's probably safer to use the fact that there's a vertical asymptote here at x equals 1. Vertical asymptotes occur, oftentimes, when the function itself is approaching infinity, as the value of x gets closer and closer to that asymptotic value. In other words, the function is undefined when x equals 1 because it's going to be so close to negative infinity that it's not even a number. So that fact says that as an asymptote at x equals 1 means that f of 1 is undefined. In order for f of 1 to be undefined, a plus b has to be equal to 0 because we can't take the natural log of 0, which means a is the opposite of b. So I go back to the other a-b relationship. I put in the opposite of b instead of a right here, add the b, and that equals 1. So just by substitution, I get a simple equation. B is negative 1/3, and a is positive 1/3. Let me take this a step further, though. Just to verify that this is correct, I want to look at the function as it's supposed to be with the proper coefficients in place. And I'm going to verify first that 4, 0 is in fact a solution to my equation, which it is. And then the second thing I can verify is by putting in 1 for x, I get the natural log of 0, so obviously that one is going to give me the asymptote. It's also valuable to go all the way to Desmos, and I know first world problems to getting out your device and everything, but here I can type in the function as I found it, And I can type in the inverse and make sure that my inverse graph is correct. I can show the asymptotes and the equations of those asymptotes, and I can show using y equals x the mirror reflection that we get. So it only takes a moment to enter these things in, but to have the confirmation that all of this written work and all of this analysis is in fact valid is an affirmation that's worth your time. What might happen when you go to Desmos is you find that what you thought was true is not, and that's an opportunity for you to learn. So don't miss out on the opportunity to use technology to support your analytical reasoning. I think what I'm going to do here is I'm going to stop the video, and I'll do another video for this problem so you can take a break too. I'll talk to you later.